When we solve rational equations, we're actually going to identify the domain restriction first. So we know that x cannot equal positive 1. The reason why we do this is because at the end, when we get an x equals solution, we need to make sure that solution isn't 1. The second thing we do, just like when we added and subtracted rationals, is identify our LCD. Our LCD in this example is just x minus 1. So my first part of my rational equation, 3x over x minus 1, I don't need to change. And then the 2 is what I need to change. That doesn't have a denominator, so I need to multiply it by x minus 1 over x minus 1. And this last part, I also don't need to change. So I'm going to rewrite it, and I get 3x over x minus 1 plus 2 times x minus 1 over x minus 1 equal to 3 over x minus 1. Now, this next step is something you can only do with rational equations because there's an equal sign. Since they're all being divided by the same thing, we can put a line straight through the denominator and forget about it. But we can only do that when we have each denominator equal to every other one. So they all have to be the same. So now all I need to do is solve the equation in the numerator. And when I do this, I get 3x plus 2x minus 2 equal to 3. And then I get 5x, add 2 to both sides, both sides, and I get 5. So x equals 1. Well, since we talked about this before, if you notice, x can't be 1, and we got 1. So this means there's no solution. And since this happened, what we call this is an extraneous solution. So x equal to 1, 1 is an extraneous solution because we identified it as being the value in our domain that it wasn't allowed to be. So there's no solution because x equals 1 is an extraneous solution. Alright, I'm going to show you one more way on how to solve rational equations. And it's a different way, so you can decide which method, I should say, you like best. Alright, so you still need to identify the domain restriction, and in this case, x can't be 0. And then you also need to still identify the LCD. The LCD in this problem is 2x. Okay, so now this is a different way. You can solve it the way we did before by making sure all the denominators are equal, or the same thing a different thing that you can do is by multiplying this whole equation by 2x. Now when you do this, you're only going to multiply the numerators, so it's 2x over 1. And when you do this, you're going to get 6x over x plus 8x equal to 14x over 2x. Now the reason why this works is because if you notice, we can simplify this, and we can simplify both of the values and our variables. So we have 6 plus 8x equal to 7. Now this is all you need to solve. 8x equals 1, x equals 1 over 8. So our answer is 1 over 8. And all you need to do now is double check and make sure it's not your domain restriction. It's 0. Since we didn't get 0, 1 over 8 is our solution. Alright, so this is a very different looking rational equation compared to the other two examples we just did. So when you have one rational equal to another, so if you notice there's no like plus 2 on this side or anything like that, when it's set up like this, all we need to do is cross multiply. So make sure you put in your parentheses, and then you're going to multiply 6x plus 7 times 2x minus 4 equal to 4x minus 1 times 3x plus 8. So, FOIL Alright, I'm going to give myself a little bit more room up top here. Okay, so now we have 12x squared minus 10x minus 28 equal to 12x squared plus 29x minus 8. Now, this is the cool part because we have an equal sign. See 12x squared? Since 1 is on both sides, you can cross these out. And now all we need to do is solve negative 10x minus 28 equal to 29x minus 8. Now when we do this,
Good morning, Mount Everest.
alright, so then we add like terms on both sides. And you end up getting negative 39x equal to 20. So when you divide, this actually doesn't simplify, so you're going to get 20 divided by negative 39. Check to make sure that wasn't in our domain restriction. So what our domain restriction was from our original, since we can't see it anymore, is x can't be 1/4 or 2. Since we didn't solve and get either of those numbers, we're good. So just remember, if you have just one rational function on either side, you can cross multiply.